let's say 16 plus 9, the square root of that. Now, if you took the square root of each of these separately, let's say we want to know if they're equal or not, then you'd be taking the square root of 16 plus the square root of 9. The square root of 16 is 4, and the square root of 9 is 3. Altogether, this equals 7. But on this side, 16 plus 9 is 25, and the square root of that is 5. 5 does not equal 7, so this is a counterexample to the idea that the sum of two squares under the radical sign is equal to the square of the first term plus the square root of the second term. Let's get back to our original equation. So we can't just get rid of this radical sign right away by taking the square root of both of these terms. What's something else we can do to isolate this half of the equation? Well, we'd want to get rid of this square root sign, so what if we just squared both sides? Then we're left with p squared plus 9 equals 5 squared, and that's 25. Well, that's a legitimate step to take. Now, we've made a little bit more room, little breathing room for our p squared. And what else can we do to isolate it at this point? Well, we could subtract both sides by -9. So we'd have p squared equals 25 minus 9, that's 16. Looks pretty good. So, from this point, if we take the square root of both sides, well, we can certainly do that because we're just taking the square root of one thing at a time. We're going to end up with p equals the square root of 16, which is 4 or -4. Thanks for listening.